All right, guys. This is an extra credit lesson for our last week of review before your AP exam. This week we're going to be focusing on FRQs. So in this video we're going to learn about a special type of FRQ question, which I'll call the derivative graph given FRQ. You could see examples of these on pages 84 through 111 of your blue books. We're going to talk about how to solve common, but of course not all, types of problems associated with these types of FRQs, and we'll also talk about how they're scored. At the end of the lesson, I will include some practice problems as well. Once again, all this is extra credit, but I would highly recommend you take part in it. So here we go. So let's begin. Derivative graph given type of FRQ. Now before we begin, let's take a look at the reference sheet I gave you. I would encourage you to print out this reference sheet. This is kind of like your notes, if you will, and the PowerPoint will have most of the examples on it for you, but this is kind of like the raw information, and it's a quick reference sheet for you. So what is a derivative graph given FRQ? Well, usually you're going to be given the graph of some kind of a derivative. And then after that, they're going to give you the problem in one of two ways. One way that they can give this to you is they could say the graph is of f prime, and they'll give you some initial condition. In that situation, you're generally going to have to start by turning it into an integral function. The other case is where they give you a graph of g and some function f, and they tell you that f is this. Now you may notice these are actually the same exact things, okay? It's just that instead of using f prime here, I'm using g, and that's because g is f prime. But they may give it to you as just a derivative with an initial condition, in which case you need to create your own integral equation, or they may give you an actual integral equation. The second one is easier, so I'm going to leave that one off, and I'm going to go ahead and do my examples based on the top one where you have to create one, okay? We're going to look at, for our first example, we're going to look at the first three types of situations here. Sometimes they'll ask you, after they give you the graph of the derivative, to find the value of a function at some point. They will ask you to find the value of the derivative at some point, and they'll also ask you to find the value of the second derivative at some point, okay? As I mentioned, for the type I'm going to do for you, you're going to have to create this equation here. And once you do that, you've got your answer to this thing here. The integral portion can be found by finding the area between the curve and the x-axis. Want to remember some other important details, like the area below the x-axis is negative. I should say negative. I'll try to remember to fix that on your guys' copy. And area above is positive. You may also want to recall that if the limits on your integral are backwards, you need to reverse them and change the sign. So for instance, if you have 5 on the bottom and 0 on top, we're going to reverse it and put a negative on the top. Typically, these questions are worth 1 to 2 points depending on how hard it is. So that's what we'll be looking at. So let's go ahead and take a look at one of these types of questions. All right, so like I said, we're going to go through those first two types right now. So as you can see, I've been given a graph of a derivative, and they're giving me an initial condition. All right, and as I mentioned, a lot of times when you have that, you might as well just start right off the bat by creating the equation that I told you. So f of x is going to be equal to f of 0, the starting value, plus the integral of the derivative from your starting value to your ending value. Okay, now in this case, the f of 0, we know that equals 4, so I'm just going to put a 4 right here, and that formula will be coming in handy for the rest of many of these problems. So when you see one of these types of problems, if they don't give you the integral function right away, you might want to start by just writing it. So to begin here with number 1, to find f of -4, we're going to take our starting amount and add to it the integral from 0 to the number we want to plug in there, which is -4. All right. Now you may notice that these numbers here are backwards, and so because of that we need to switch them around, and as a result we'll put a negative in the front. So now we have 4 minus the integral, and the integral is going to be the area under the curve from -4 to 0. So here's -4, here's 0, so basically this shape here. We need to find the area of that whole thing. Now I'm going to break this up into two pieces. I'm going to break it up into a triangle, and then the rest of it is a trapezoid. So for the area of a triangle, we do 1/2 the base times the height. Now the base of that green triangle is 1 and the height is 2, and this area simplifies to 1 as a result. For the trapezoid, as you guys may recall, the area of a trapezoid is given by taking the height of the trapezoid, which in this case would be this length here, dividing that by 2, and then multiplying it by the sum of the bases, which is this and this, the bases of the parallel sides. So one of my bases has a length of 2 and the other one has a length of 1, and then that ends up giving me 9 over 2, which is about 4.5. So that one's 4.5. So we have 1 plus 4.5 for the total area there, which means I have 4 minus 5.5, and 4 take away 5.5 would be -1.5. So let's go ahead and put that answer in there. Let's go ahead and move, and once again, I think that would probably be a question that's worth 2 points. I think they would give you 1 point for creating the function yourself. And then they would give you 1 point for calculating the answer correctly. So I believe that would be a 2-point question. Now, if you were given one of these types of FRQs where they don't make you create the equation, they actually give it to you up front, well, then it might only have been worth 1 point. All right. I'm pretty sure the other two would simply be 1-point questions. So let's go ahead and take a look at number 2. Number 2 wants us to find f prime of -4. So instead of f of -4, they want us to find f prime. Well, that means I need to take the derivative of this function here. Now, there's an easy way and a hard way. I'm going to do the hard way first, and then I'll show you the easy way. So the hard way is, let's take the derivative of this whole thing here. The derivative of f is f prime, which is what we want. The derivative of 4 is 0, so that just goes away. And the derivative of an integral leaves me with f prime of x. And so what that basically tells you is this function is simply this graph down here. So if they want f prime of -4, all you have to do is find the y value on this graph at x equals -4. So here's where x equals -4. What is the y value at that point? It is 0. Okay, so that's how we can do that particular problem. Let's go ahead and do one more. And I believe this last one would also be worth only 1 point. Now, what is f double prime? Well, this is a graph of f prime. Well, this is the derivative of f prime. So I'm going to write that. You don't have to write this. You can if you want to. But f double prime is the derivative of f prime. Now, another way of saying that is f double prime is the slope of f prime. So in other words, what is the slope of this function at x equals -4? Or I should say, what is the slope of this graph at x equals -4? So at x equals -4, we're here. So I just need to find the slope of that line. It looks to me like the rise would be going from -2 to +2. The rise is 4, and the run is 2. So rise over run is 2. And once again, I think both of these ones would be worth 1 point. I think the top one could be worth 1 or 2 points, depending on how hard it was to arrive at that solution. All right, guys. The next type of problem that we're going to be looking at is finding the maximum and the minimum. And by that, I mean the absolute max and absolute min. And for that, basically, you're going to do the candidates test. Okay. Now, you guys know that when you do the candidates test, you're going to plug in 2 types of numbers. One type of number you're plugging in is the endpoints. The other type of numbers are the critical values. Now, the critical values are where the graph touches the x-axis. And that because that's where the derivative equals 0. All right. You're going to have to use that little formula once again that I said you would need to find at the beginning. You're going to have to use this to find all of your outputs. Okay. And these questions are typically worth 2 to 3 points. So let's go ahead and do one of those. So problem type 4. It's the same graph and the same initial conditions, so nothing's new there. And so we're still going to be using the same the same position formula, or whatever we want to call that, integral formula. All right. So they want us to find the absolute min and max. So if you want to do that, you're going to put your input variable on the left, and whatever function you're trying to maximize, which in this case is the f, on the right. Now your critical values will be the left endpoint and the right endpoint. So we're going from -5 to 4. And we're looking for our critical values, which are those places where the function touches the x-axis. So we have here and we have here. Now just so you guys know, this one is a critical value. But if it doesn't cross the x-axis, it's not going to give you a maximum or a minimum. Maximums and minimums happen only when it actually crosses the x-axis. So I'm going to go ahead and save myself some work, and I'm going to avoid finding that one. But if you did include it, you would just be doing more work. So long as you did everything right, you wouldn't get the wrong answer, and they wouldn't take points away. So my critical values then are at -4. And also at 3. Those are the places where it crosses the x-axis. All right. All right, now we already found f of -4 on the last slide, and we found that that was -1.5. So let's go ahead and work backwards again. Let's go to the -5 now. So to find f of -5, it's going to be the starting amount that they gave us, which is 4, plus the integral from 0 to -5. Okay. All right. Well, we've already calculated the area of this weird shape here. What did we find that to be? I'm trying to remember now. I think it was 5.5, if I'm not mistaken. And then but since we're going to -5 this time, we have to include this triangle. That triangle has an area of base times height. 1 times 2 is it's going to be 1, but since it's under the x-axis, it's negative. So let's come up here to our integral. We have f of -5 is equal to 4 plus, and actually we have to flip the limits again because they're backwards, right? So it's going to be minus the integral from -5 to 0 of f prime. Okay, so we have -1 plus 5.5, and so that's going to be 4 minus 4.5, and 4 minus 4.5 is 0.5. And so this one here is equal to 0.5. That's our final answer. All right, let's do the next one. Now we want to find f of 3. So if I want to find f of 3, I'm going to start at 0 and go all the way up to where x equals 3. Now that gives me a couple shapes. I've got a ramp here, and then we have another ramp located here, and then we have a triangle located there. All right, so let's find the areas of all those pieces real quick. So the area of a triangle is pretty simple. It's 1/2 base times height. The base of that blue triangle is 1 and the height is 1, and therefore the area of that little triangle is 0.5. All right, let's do the ramps. And you guys might have forgotten how to do the area of a ramp. I'll remind you of that here. The area of a ramp can be found by finding the area of a square that has the same base as the ramp and then subtracting away from it a quarter circle. And the result will be the ramp. And therefore the area of a ramp, I'll just put R there for ramp, is going to be the area of the square that has the same base as the ramp minus the area of the quarter circle whose radius is the same length as the base of the ramp over 4. Okay, so for this particular one here, the purple one, the base of this ramp is 1. So it's 1 squared minus pi 1 squared over 4, which is 1 minus pi over 4. Oops, just the pi there. And the other ramp, the orange one's actually the same. So we found all of our little areas there. So let's go ahead and label them. This purple one here is 1 minus pi over 4. The orange one here is also 1 minus pi over 4. And then the blue one, the blue triangle here, was 0.5, or you could just say a half. Doesn't really matter. All right, so we're ready to go ahead and calculate f of 3 then. F of 3 is 4 plus all those little areas from 0 to 3, which we just calculated there. So that would be 1 minus pi over 4 plus 1 minus pi over 4 plus 0.5, right? So if I put the 4 with the 1 and the 0.5, I get 6.5. And if I put the two negative pi over 4s together, I get negative 2 pi over 4, which reduces to pi over 2. And so I've got 6.5 minus pi over 2. Now I'm going to write that answer there because that's an exact answer. But eventually in this problem, I'm going to want to find out which number is the biggest and which one's the smallest. So I'm going to write the exact answer there, but I'm also going to put my estimate. I want to put the exact answer because they are kind of picky about being correct to 3 decimal places. But when we come to rounding, we're going to have to estimate a little bit. So we have 6.5 minus pi over 2. Now pi is basically just 3, right? And so if I have 3 over 2, that's 1/2, or 1.5, I should say. And 6.5 minus 1.5 is 4. So we're going to estimate that as roughly 4. All right. We have one more that we need to calculate here. So let's go ahead and do that. We need to find out what f of 4 is. So f of 4 is equal to 4 plus the integral from 0 to 4. In other words, the area under the curve from 0 to 4. So from here all the way over to 4. So I've got my ramp, my triangle, and now another triangle over here. So we've already had these other ones. We had this one as 1 minus pi over 4. We had this one as 1 minus pi over 4. That's not a ramp, that was a triangle when you rewrite that. Then we had the triangle here, which was 1/2. And then this triangle is also a half because it's the same shape, it's just upside down. And since it's under the x-axis, it's negative. So f of 4 is going to be equal to 4 plus, and then 1 minus pi over 4 plus 1 minus pi over 4 plus 0.5 minus 0.5. All right, so the 0.5s go away this time, but I can still put the 1s together with a 4 to make 6, and I can still put these together to get minus pi over 2. And so I'm going to go ahead and put that there as well, 6 minus pi over 2. And as we already said before, pi over 2 is basically going to estimate to about 1.5. So if I subtract 1.5 from 6, I'm going to end up with 4.5. And that makes me realize I just did this one a little wrong. 6.5 minus 1.5 isn't 4, it's about 5 actually. Oops. All right, so there's that. Let's go ahead and answer the question now. The question was really, what's the max and min? Well, it's the biggest and the smallest number. So this one seems to be the biggest number, and the smallest outcome seems to be negative 1.5. So there's our smallest number. And so we would say the following. We would say that our absolute minimum is negative 1.5, and our absolute max is 6.5 minus pi over 2. And I would encourage you guys to put the actual answer, not our estimated answer, just because they do want accuracy to be there. All right. And typically these would be like a 3-point question, in case you were wondering. They're going to usually give you 1 point for finding your critical values, 1 point for probably just finding the correct outputs here, and then 1 point for answering the question and finding what the max and the min is. So it's about a 3-point question. Critical values, outputs, answer. All right. Move on to our next thing here. All right, the next thing we're going to look at is how to find relative extrema. We're also going to talk about how to find critical values. Those things kind of go together. Critical values, we'll start there. Critical values are those places where the derivative equals 0 or where the derivative is undefined. Okay, now if you're looking at a graph of the derivative equals 0 anytime it touches the x-axis. We've already talked about that. The derivative is undefined if there's no point on the graph at that spot. So that's another place where the derivative would be undefined. Now, if they want you to find the relative extrema of f, then you can use these facts here. F has a relative max when the derivative goes from positive to negative. Now, let's understand why that is. The derivative is the slope of f. So if the derivative is going from positive to negative, that means the slope of f is going from positive to negative, which means that that creates a relative max. Okay. Now, since we're looking at a graph of f prime, though, this would be like the graph of f. But since we're looking at a graph of f prime, the way it looks on the graph of f prime is it's going from above the x-axis to below the x-axis. So this is what the graph of f prime would look like in that case. So f would look like this, the top, and then f prime would look like this. It goes from above to below, which means the slope of f goes from positive to negative. So f has a relative max when f prime goes from positive to negative. This happens when the graph of f prime goes from above the x-axis to below the x-axis. Contrary-wise, f has a relative minimum when the derivative changes from negative to positive, and that happens when the derivative goes from below to above. Okay, so let's go ahead and do a couple of problems like that. All right, so same graph, same instructions. The critical values of f are located where f prime is 0 or undefined. Okay, now just so you know, a lot of times on these questions, they are going to ask you to explain. So I should probably have that on there. That's an important part. These questions, each one of these could be worth 2 points. 1 point is for getting the correct answer. And 1 point is for the explanation. Okay, so we do need to know how to explain these types of problems. So let's begin. Let's find the critical values of f. Now, f has critical values when f prime is 0. Now, there's a few places on this graph where f prime equals 0. F prime equals 0 here, here, and here. Anywhere it touches the x-axis, f prime is equal to 0. Now, I'm not going to do the next part. The next part says f has critical values when f prime is undefined. And the reason I'm going to skip that is because this function is never undefined. It exists everywhere on the interval from -5 to 4. There's no holes or gaps or jumps or anything weird like that going on. So this would be the answer to number or part A here. So once again, you would get a point for your answer and you get a point for your explanation. Okay, let's go ahead and take a look at part B now. Let's find the relative minima of f. So as I mentioned on our little reference sheet there, f has a relative min when f prime changes from negative to positive. In other words, whenever the graph of f prime over here goes from below to above. Well, that happens right here. Here we're below, and then after that, we're above. And so it's changing from negative to positive right here at x equals -4. So we would say this happens at x equals -4. Now, I don't see that happening anywhere else on the graph, and so that would be our answer. Once again, 1 point for the answer, 1 point for the explanation. You'll notice that I didn't put in my explanation that f prime changes from below to above, and that's because you don't need to. This is really the important thing you need to say. The only reason I added that on the reference sheet was so that you guys can know what to look for on the graph. All right, let's go ahead and do part C. Part C. Let's find the relative maxima of f. F has a relative max when f prime changes from positive to negative. This happens at, well, let's take a look-see. Over here, f prime is positive, and then after that it's negative, and therefore it must be switching at that point there. So we would say x equals 3. Once again, 1 point for your answer, 1 point for your explanation. All right, let's go ahead and move on to another type of problem. All right, this is the last set. We're going to talk about concavity and points of inflection. All right, so f is concave up when its second derivative is positive. Now, since the second derivative is the slope of the first derivative, which is the graph that they give us, then f is concave up when f prime is increasing, or it has a positive slope. So if f prime is increasing, that means the slope of f prime is positive, which means the second derivative is positive, which means f is concave up. The opposite is true for concave down. F is concave down when the second derivative is negative, which means that we're looking for those places where the second derivative graph is decreasing, or in other words, has a negative slope. Now, f has a point of inflection when f double prime changes signs. A point of inflection is where a graph changes concavity, like from concave down to concave up. So somewhere like right about there would be a point of inflection. Okay, so when the second derivative changes signs, you have a point of inflection. And that would mean when we're looking at a graph of f prime, that would mean the graph of f prime would go from an increasing to a decreasing value. So in other words, if we're looking at a graph of f prime, a point of inflection would look like the top of a curve like that, or maybe the top of a cusp like that. Or it could be the bottom of a curve or the bottom of a cusp. Okay, that's how you would find it. Now some of you guys might be thinking, well, Mr. B, I thought those were relative extrema. Well, these are the relative extrema of f prime. But the relative extrema of f prime are the points of inflection of f. So you have to remember what type of graph we're looking at as you're interpreting these things. So let's go ahead and do our last set here. The graph of f prime, the derivative of f is given below once again with the same graph. Let's find where f is concave up. All right, so f is concave up when f double prime is greater than 0. This happens when f prime is increasing. And that's at, this is on the following intervals. So from here to here, f prime is increasing. And from here to here, f prime is increasing. And so we would say this happens on the intervals of -5. I'll put it in parentheses. -5 to -3. And 1 to 2. And that's it. All right, let's go ahead and take a look at the next question. Next question is asking us, where is f concave down? So f is concave down when f double prime is less than 0. This happens when f prime is decreasing. This is on the intervals that follow. Here we're decreasing, here we're decreasing, and here we're decreasing. All right, so let's go ahead and put those intervals. So -3 to 0, 0 to 1, and 2 to 4. There you go. And once again, guys, I haven't said it yet on this slide, but the same principle holds. You get 1 point for your answer, and you get 1 point for your explanation. All right, same for both of these. So I would say these are 2-point questions. All right, last thing that we'll do is part C. Find where f has a point of inflection. I'll put it up here. F has a point of inflection when f double prime changes signs. This happens when f prime changes from increasing to decreasing, or vice versa. And that happens in the following locations. Anywhere on my graph where I'm going from yellow to pink or vice versa is going to be a place where we're changing from increasing to decreasing. So that would be a point of inflection, that would be a point of inflection, and that would be a point of inflection. And so we would say x equals -3, x equals 1, and x equals 2. All right, and there it is. So that's it. Once again, that's not all the types of questions that they can ask. These are the really common types of questions, though, that they do ask when they ask them. And so these are good problems to be aware of. So I would encourage you guys to print out these questions, have the answers written down, staple it to the reference sheet that I gave you, and use it as a study aid the few days before your exam. All right, we'll do some more of these things in our next lesson, so we'll see you guys then. Have a good day.